The signal arrived without fanfare, just a quiet stream of data sliding across a monitor in NASA's mission control. At first, the engineers thought it was simply another routine transmission from Perseverance, the rover that has been patiently crawling across Jezero crater for years. But then someone noticed the numbers weren't following any geological pattern they recognized. The room slowly fell into a kind of focused hush as the data was examined again and again, until the impossible began to take shape. This might be the clearest hint of life ever detected on Mars. For as long as we've looked up at the red planet, we've imagined it might have secrets to share. Ancient astronomers mistook lines on its surface for canals built by alien civilizations. Our early spacecraft searched for chemical imbalances or living microbes but came up empty-handed. Even when riverbeds were discovered and minerals formed in water were confirmed, we still couldn't answer the question that sat at the heart of every mission: did life ever exist there? Perseverance was built to chase that answer more directly than any rover before it. Its instruments can scan rocks for organics, detect subtle chemical patterns, and peer into the microscopic textures of Martian sediments. Recently, while examining layered stones deep within the crater, the rover found something that stunned everyone involved. Complex carbon-based molecules appeared not as scattered fragments, but as organized patterns, arrangements that, on Earth, almost always point toward biological activity. They looked deliberate, as if shaped by natural processes that were once alive. Then came something even more surprising. For years, Mars has teased scientists with sudden bursts of methane in its thin atmosphere. Methane isn't proof of life by itself. Geological processes can produce it too. But this time, the methane rose and fell in a seasonal rhythm, one eerily similar to the cycles seen in biological systems on our own planet. It was as though Mars were exhaling. The imagery added another layer of mystery. High-resolution scans revealed delicate, rippled structures within ancient rocks. Their appearance was oddly similar to stromatolites, the layered formations created by microbial colonies in Earth's primordial oceans. The resemblance was so strong that one researcher admitted privately that, if these samples had been found on Earth, the conversation about their origin would already be over. But Mars is a different world, and caution is woven into the scientific process. Scientists remember too well the excitement of 1996, when microscopic shapes inside a Martian meteorite were interpreted as possible fossils. Debate raged for years before geological explanations were accepted. This time, experts from around the world are scrutinizing every possibility, eliminating mineral reactions and chemical coincidences one by one. And yet, despite all the skepticism, the data stubbornly points in the same direction. These clues arrive against the backdrop of everything we already know about Mars. Billions of years ago, it had rivers, lakes, and perhaps even a global ocean. Its atmosphere was thicker, its climate temperate. It wasn't the frozen desert we see today but a world where water moved freely and chemistry thrived. If life ever found a foothold beyond Earth, Mars seems like the most likely place it happened. The idea alone has electrified scientific communities. No official announcement has been made, everything is still being analyzed and tested, but the sense of anticipation is palpable. What Perseverance has found isn't a single anomaly or a curious rock. It's a network of independent signals all hinting at the same astonishing possibility: Mars may have once been alive. As the rover continues its steady trek across Jezero crater, it is caching these unusual samples, sealing them into small tubes that will one day be delivered back to Earth by a future mission. When those samples finally arrive in advanced laboratories, scientists will be able to examine them at scales no rover camera could ever achieve. And if even one microfossil appears under a microscope, one unmistakable shape left behind by an ancient Martian organism, human history will shift in an instant. For now, all we can do is wait, And imagine what it would mean if the universe has been whispering to us from our neighboring planet all this time. While researchers debate the new findings, the rest of the world is already caught up in the implications. The thought that Mars might once have been inhabited doesn't just change science, it reshapes our sense of identity. For centuries, human beings assumed life was unique to Earth, a fragile anomaly in an otherwise empty cosmos. If microbes once lived on Mars, or if traces of them still lie hidden beneath its soil, then life may not be an exception at all. It may be a natural consequence of planetary evolution. Religious scholars, philosophers, educators, and everyday people are beginning to grapple with that possibility. Some imagine how ancient Martian ecosystems might have looked, whether microbes formed mats along the edges of warm lakes or clung to mineral-rich hot springs. Others wonder if life persisted longer than we think, sheltered deep underground where warmth and water might still exist. A few even speculate about the broader implications. If life emerged independently on two planets within a single solar system, then the galaxy could be teeming with biological worlds. Such questions used to belong to science fiction, but now they sit on the edge of scientific reality. The discovery of even the simplest fossil on Mars would be enough to ignite a new era of exploration. Missions to the icy moons of Jupiter and Saturn, places like Europa and Enceladus, where oceans lie hidden beneath thick sheets of ice, would take on new urgency. Telescopes searching distant exoplanets would be recalibrated with a clearer sense of what signatures to look for. The entire field of astrobiology would accelerate. Yet these discoveries also pose difficult ethical questions. If Mars once hosted life, should the planet be treated as a protected environment? Should future human explorers tread lightly, aware that they could disturb or contaminate fragile remnants of an alien biosphere? Some argue that safeguarding Mars should take precedence over human colonization. Others say exploration and protection can coexist. Whatever the stance, the debate has been reignited with a new intensity. Meanwhile, Perseverance continues its work, inching through landscapes shaped by ancient water. Every drilled core sample, every scan, every chemical reading could be another piece of the puzzle. The mission teams know how historic these moments could become, and they proceed with a kind of reverence. They double-check every instrument reading. They replay every transmission. This isn't just another planetary survey. It may be the first chapter in a story humanity has been waiting to read for millennia. What happens next will unfold slowly. Peer-reviewed studies will test, challenge, and refine the interpretations. The Mars Sample Return mission will gather momentum as international teams coordinate the complex sequence of launches required. And somewhere in the early 2030s, if all goes according to plan, a small container carrying pieces of Jezero crater will touch down on Earth. Scientists from across the globe will gather around the sealed chamber, knowing that what lies inside could confirm one of the greatest discoveries of all time. But even before that moment arrives, even before a final verdict is reached, something significant has already changed. Humanity is looking at Mars differently. It's no longer just a distant, lifeless world. It's a planet that may hold memories, tiny, chemical, fragile memories, of a time when it pulsed with biology. The mere possibility of that truth has expanded our perspective. Every time we send a rover or a probe into space, we stretch the boundaries of our imagination. We do it because we want to understand what kind of universe we live in. We do it because curiosity is part of who we are. And now, as these clues accumulate on a silent world millions of miles away, we are closer than ever to answering a question older than civilization itself. If Mars once hosted life, even briefly, then life is not a miracle chained to Earth. It is a phenomenon the universe seems willing to repeat. And somewhere in that realization is the beginning of a new